Okay, RREF number 12, 3 by 4. Number 20, just write the augmented matrix. Done. Number, make sure you put a 0 for y. Yes. Number 36. Did you guys get 36? I like that one. It made you show that you, now hold on for the test. Hold on for the test. Did number 36 make you show that you know how to do it without doing the whole thing? Nice. How do I get 1 and -1? Well, I have to multiply by a -1/3. Why would you multiply by a -1/3? What were they getting? What step? Yeah, they're getting a leading coefficient of 1 in the first column. So, answer -34. Number 46. Is it in row echelon form? Yes. Is it in reduced row echelon form? No. He's the problem. He should have been a 0.
Let me see.
Huh?
Real quick.
Yeah.
I see it's not, but you know that Z is 0. So you could put a 0 in the place of the Z.
If you were solving, yeah.
So
But is it in? You're not a robot.
Is it a trick?
You see that,
There you go.
but it's not a trick. Right now, it is not in the correct form for RREF. Number 78.
Ooh.
Ooh, you guys started, and what happened? 0, 0, 0.
Oh wait.
Now, what was weird when you got 0, 0, 0? Because you would have gotten your leading coefficient of 1. Boom. Get the 0. Uh-oh. You're all gone. That would have told you, true statement, let somebody equal A. But why not Z? Because this is only what kind of system? A 2-variable XY system. So therefore, I'm not going to let Z equal A. I'm going to let who's the second variable I wanted to get but disappeared. Let Y equal A. And then plug into X and then B. Dun, 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 dun. Is that okay? Yeah. So it's like the Z equal A. Remember, if we get like a whole equation of zeros, if we get a whole row of zeros in the matrix, that tells us it's possible, but infinitely many. We let somebody equal A, whoever's row got canceled out. Does that make sense? Then we only have 102? Woo! Did you guys have to make the system yourself?
Yeah.
They were in, is it investing? They were investing $2 million. Ooh, that'd be nice to invest. Okay, so
Why do you need to invest? Oh my goodness.
maybe it's a business, I don't know. So they're investing $2 million. 3 different amounts, X and Y and Z, at 3 different percentages, 3 different rates, and all of those rates add up to get how much interest? Those investments, right? Not like loans. Okay, no. So 8%, 9%, 12%. Somehow the investments add up to 186,000. And then last but not least, we knew that X is 2Z or something like that. The amount in the Z account is double, no. The amount in the X account is double the amount in the Z account. Maybe they had to like get it to where it was equal to 0. Long story short, you have a system. What's the very first thing I would have told you to do? Looking at this matrix, what's the very first thing you should have done? Yeah, you could have switched the first and the last if you wanted to, but I think there's something that's even a little bit more critical for you possibly doing this by hand. Do we like this by hand? How do we get rid of decimals? The same way we get rid of fractions. Multiply both sides by something. The reciprocals for fractions, that would have been good. Put over here, actually, common not. But for decimals, just multiply everything by almost 100. So we can move them 2 decimals. Multiply right by 100. Move it 2, move it 2, move it 2, move it 2. And all of a sudden, life just got a lot easier. Then, now they kept it for a little while. That's kind of silly. I would have gotten rid of those decimals right away. Then you go. Oh, they just did row echelon form? Well, I would have done reduced row echelon form and had an answer. Lame sauce. They did row echelon form, they set it up, and they said back substitute, dun, 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 dun. But the crazy thing is, kiddos, if this is a calculator problem, which it looks to be, well, no, you could have done this without a calculator. You would have just had to get rid of your decimals right away. Put 2 decimal places where we want, I don't know. Probably a calculator problem. Couldn't you just RREF your matrix? probably be an RREF your matrix. If I ask for work, I guess you could show me, but I wouldn't ask for work on something with as big a numbers or decimals. I was just trying to let you guys know. Final answer is, it's borrowing. You guys, that makes more sense. Is Zoo borrowing $2 million? Anyway. They borrowed this at 8%, this at 9%, and this at 12%. Why does it make sense they're borrowing less money at a higher percentage? Oh, I'm applying to real life. Come on, sillies. Why would it make sense that they borrow the least amount from the highest percentage rate?
Just because it's
I guess it's 200,000 at 9%. That's lame. Does anybody have an idea as to why they're even doing 3 different loans?
No.
Oh, I know
Why?
why. Because if you like a bunch of money, and then 12% of like, let's say $1 million is, what is that? 1,200. And then let's say you split it up, 12% of each one is less money.
Yeah. So first of all, Brandon's saying, well, you don't want to borrow everything at 12% because then you're going to have a higher percentage rate, right? The higher the rate, the more money you're going to have to pay to the bank for letting you borrow the money. And number 2, just because you need $2 million, does that mean one place is going to loan you all $2 million? In the nice world, maybe.
But this is not.
If it's like family, maybe. But if you want $2 million, it could be that this nice 8% one would only loan them 1.2. Maybe the 9% would only loan them 200,000, so they needed the rest of the money, and they're like, stink, we have to go with the higher percentage rate. Anyway, yeah. Beware percentage rates. Life lesson, beware credit cards. Anyway, personal finance. So, are there any quick questions on odds? Going once? Odds. Going twice? So, notes open. Let's go back to the example that you guys were, where'd he go? Somehow he got turned off. Let's get out of that because you guys don't need it, and there he is. What'd you guys get for letter little a, which is a plus b? 3, 7. Okay. So when you read off the matrix, you do the same thing as your calculator. You work your way across next row, right? Letter B. How about A minus B? Sound good? Oh, 3 negative 9. I swear I heard one. Letter C. What'd you get?
3 negative 3, 6 negative 3. Let's see if we're doing this one.
Letter D. Did you guys get it right? Did your calculator prove it to you?
Negative 1, negative 1, 8, negative 19.
Woo! All right. Are we okay with the graphing calculator? How do you put something like letter D in your calculator real quick? Second matrix. You go to edit, you put in A, you put in B, both as 2 by 2s, right? Cool. So in the matrix menu, you can make a matrix in the edit. You can pick matrix operations for your home screen from the map, and you can get matrix names from the original menu that pops up when you first get it, right? We're okay with our calculator? Or you will be when you try to cheat with it this weekend? Okay, son. Just kidding, don't cheat. What's due on Monday? P.S. Looking in the back. Not just corrections, but good. A2. But hold on. A2 is nicer, isn't he?
Yes.
I suppose. Question, the same way you can multiply an entire matrix by a scalar, aka you guys just did 3a and 2b and then subtracted, right? 3, just multiply 3 by everybody. 2b, you do 2 times everybody in the B matrix. The same way you can multiply everybody by a scalar, you can also factor out scalars to make a matrix nicer. For instance, in the matrix that's given to you, what would you want to factor out to make it look prettier? Yeah, a 2, but a 2 in a denominator, so a 1/2. True? What would you get left on the inside? Now, what would be the purpose of this? Let's say I were to call this one matrix A. And let's say I was to give you another matrix, for instance, like matrix B. Let's do something like, I don't know, let's do 3, let's do 7, let's do -2, and let's do 11. And let's say I was to give you something like, hey, now all of a sudden you need to solve for B minus A. Now, if you really don't like fractions, and this is like a really, really, really don't like fractions problem, you can avoid all the fractions until the very end. But it's not super straightforward as to how. Meaning, I think Lukey started saying this, keep the 1/2 out. Some of you are like, yeah, I don't want to put that together, right? So if you really don't like fractions, what would you have to do? Well, hold on, let's set it up. You could replace A with 1/2, 1, -3, 5, 1. Question, is it legal math to say, sweet, let's put these together now? No, because who are you totally ignoring? Okay. We can't do that, but what could we do? Anybody have a mathematical way of dealing with the 1/2 later without distributing it in?
Multiply them both by 2.
So multiplying like that? No, that's not what you meant. But that's what you would have to do.
Both sides.
If we had 2 sides of an equation, we could multiply both sides of the equation by 2. We could technically do something like if you guys wanted to, I suppose. If you want to multiply by 2, you would have to put this guy on one side of the equation. You could multiply him by 2 and him by 2. Does that make more sense? You could do that, which is ultimately what I was showing. But it looks maybe a little bit nicer to some of you. Now what? You get 2 times this guy. Well, wait a minute. We can do 2 times a matrix, right?
Yeah.
Okay. What's going to happen as I do 2 times that matrix?
6, 14, -4, 22.
Nice. What happens when I do 2 times that guy?
It will be 1, 5, -3, 5, 1.
And over here I have 2 times b minus a. We're basically delaying the inevitable of having to worry about the 1/2. And we're able to work with whole numbers for a little while. So whole numbers over here. Now I can go ahead and distribute, right? Remember, it's subtraction. If you want to, you could do what we normally do with subtraction. We can distribute it to everybody and like just flip everybody's signs. That's okay. And then just add. Either way, you end up with what resulting matrix? 6 and -1 would be 14 and 3 would be -4 and -5 would be, and 22 and -1 would be.
Is that a minus? Shouldn't that be a minus?
It was a minus, but I distributed it in. Look at the color change. You see it?
Oh, I see.
Yeah. I was trying to save the seals. So now I have 2 times b minus a. Now what do I do? Divide by 2, aka multiply by 1/2. You could leave it like that and say dun 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 dun. Or if you were trying to make it match, you could think about what would happen if you brought it in the 5 halves, the 17 halves, the -9 halves, the 21 halves. Either way. Kristen, go ahead, kid.
So since you multiplied it by 2, why'd you have to go back and divide it?
Well, when I multiplied it by 2 up here in this step, hold on, I can't see it all on the screen. There we go. When I multiplied by 2, I had to multiply both sides by 2. But my original problem, I was just trying to find b minus a alone. Does that make sense? So to be legal, I multiplied one side and the other side, but I was only wanting B minus A, so once I came down here, I had 2B minus A. And I said, no, get that alone. Does that make sense? So basically by R multiplying both sides, by multiplying both sides, you're basically ignoring the 1/2 because you don't want to deal with him right now in order to solve. Does that make sense, kind of guys? So I'm not saying you always want to factor out stuff from matrices. Actually, they'll probably rarely ask you to factor out. But just the fact that you can, just be careful. Just because you factor out doesn't mean that you can, like in this one. Some of you might have very easily made the mistake of, hey, take all the nice numbers and put them together with all the nice numbers and the 1/2, I don't know, I'll just deal with them later. Make sure you're still following legal math practices when you're trying to ignore like fractions or decimals. Okay, let's see what else this section has to offer. Okay, memorize, just kidding, don't do that.
Whoa.
Question. Which ones make sense and which ones don't?
Number 4 does not make sense.
Okay, so this one makes sense, maybe you don't need to write it. This one makes sense.
Oh, I thought it was just one
On
time.
cycle.
What does it mean? If I do 2 times 3 times A, it's the same thing as 2 times 3 times A, right? Okay. It looks different though, it looks weird.
No, these aren't that bad.
But maybe that makes sense. If I multiply a matrix by 1, it's itself. If I multiply by a scalar, the sum, I can multiply and distributing. Yeah, that one works good. Works pretty good. Number 7 might be the kind of weird one. Except, the only reason it's weird is why did I put the NN thing down there? You cannot add matrices unless they are of the same order. So that's kind of for everybody in this entire table. You cannot add matrices unless they're of the same order. Okay, so that's something to keep in the back of your mind. But otherwise, as long as they are of the same order, which they said they were, they said, okay, they're the same order, then I think all of these make sense. The ones that don't make sense are when we start multiplying. Ooh.
Hello.
Matrix multiplication. This is where it gets exciting.
I'll show him.
Well, I remember in the SAT, I forgot that if you go like across and then this, they get
So we're not writing
Matrix multiplication. So wait, Luca,
yeah,
this was on the SAT?
2 problems.
Ooh. Juniors, you heard that, right?
Yeah, and in the
How can you
SAT.
remember that?
Junior college? Yeah.
When did you take it?
Oh.
Juniors, when did you
just
take
got
your SAT?
March.
ACT or SAT? Oh, I'm not taking SAT.
Probably start towards the end of your junior year. That way you have time over the summer and or
Yeah.
fall to take it again before college. It ultimately depends on how many times you want to take it, aka how much of a perfectionist or what things you're aiming towards that need a certain SAT score.
How many times?
As many as you want. It doesn't necessarily look good though if you take it over and over and over and over again, unless you're trying to, like, some people take it over and over again aiming for like a perfect score or something.
Well, I'm not that. I'm just trying to get
Or aiming for a scholarship or
Wait, don't
something.
you just want to see that you took it? Do you actually have to get it? I didn't get it.
So it might be better to, the first time you could like not study at all and just wing it, but I would probably say,
I wouldn't waste all your privilege.
if you're not taking some practice ones and already having an idea of how you're doing,
You don't
you
use
probably
it
want to
for, like,
study, not waste one.
December of senior year. That's the worst.
Did you do
Is that
that?
No,
Oh, I was
but
like,
my
Some
friends
people-
did it and it just didn't go well.
oh, that's so sad.
Yeah, you want to have apps in, I mean, I'm sure counselors are telling you this, but you want to have apps in October-ish. Like done, maybe September-ish is probably even better.
So you can get early decision, right?
Yeah, so you can do early decision and or colleges don't like to see things turned in the very last day. They know the date, they start making decisions earlier from people that turn in apps earlier, like not even official early decision. And you can't, for some applications and or for some things that you're going for, like honors colleges, etc. If they require a certain SAT score, you have to wait after you take it until it gets recorded and reported back, etc. So biggest advice seniors usually tell juniors or start thinking early about college, like during the summer, which ones you want to apply to, look and see what you need to apply. You need to write essays, etc. Think ahead. Not to stress you out, just to give you some, right now, junior year, some college advice. Depending on the college, they might ask you for updated certificates. They might ask you to based on that. But they can't see like what you're in, they can't ask what age you stay in that class, etc. Alright, you guys got it? All written down, ready to go? Okay, so, let me unfreeze it. A little more complicated than scalar multiplication. Scalar says just take it to everybody. But hey guys, we know this because we took algebra once upon a time. Meaning, if you had something like this, isn't that a little bit harder than something like, isn't this one a little bit easier than that one? Now it's the same idea kind of there. And maybe in that way this is a little bit different, but long story short, one of them was easy and one of them got a bit more complicated. Now, matrices are even a little bit more different, but couldn't say complex because that would be imaginary. Anyway, so many English words have math meanings. Cross down is my silly way of remembering. Cross down. Remember cross down, then you remember you're supposed to go across first, then down next. What? Ready? Row by column. When you have a multiplication, number 1, AB, you'll see it soon, but AB does not necessarily and almost never equals BA. Wait, but that makes sense. Too bad. Once we learn how to multiply, that will no longer make sense. Well, that will make sense. You'll understand why it cannot go both ways. Here's the long story short of the process. Make a big old matrix. Give me room. In order to find, I'll give a quick example off here to the side. Remember how when we're trying to talk about entries of a matrix, we talk about them as in terms of like the first row, first column, right? If we're talking about the multiplication, A times B, the first row, first column element, which is going to go right here, the first row, first column entry is going to be found by multiplying. Now, let me go ahead and actually name this C because we have A's and we have B's. We'll say C11. It's going to equal A11 times B11 plus A12 times B12. And this is all for this little guy right there. So, ready? What is that? Yeah, you got it. That is the first times the first, aka -1 times -3, plus go across the second, go down times the second. Think dot product, kind of. Yeah? Cross down.
So, Missy, so it should be A12, B21.
Oh yeah, did I write that backwards? I did. Thank you. Cross down. We're not going over, we're going down. A11, B11, A12 go across, B21 go down. There we go. Now, when you actually do that, and if you're doing mental math, you can say, oh, no big deal. That's going to end up being, in your head, +3 minus 12, which would end up being +3 minus 12, -9. Now, how do we find the next entry? Next meaning, remember in the graphing calculator you go across, right? The next entry would be this entry. You're going to cross down, which is what we did first, then you're going to cross over. Cross down, cross over. What do I mean? A11 times crossover. It's time to do the next column. So negative 1 times 2. Go across 3 times 1.
So A11 times B.
So you cross down and then cross over down.
B22.
And if you can get really good at this, you can say, sweet, I'm crossing over to the next column, so I have negative 1 times 2 is negative 2, and negative 2 plus 3 times 1, negative 2 plus 3 is 1. So we work by rows and we work by columns. Rows of the first and columns of the second in our multiplication. Rows of the first and columns of the second. So we have just completed our first row. You see it? Negative 9, 1. Didn't we complete our first row? Okay. We used both the elements in the first row and we associated them with both the columns in the second one. So now what is it time to move on to? Now guys, remember I'm recording this and I'm showing the step-by-steps. If you want to go back and watch the recording, you can watch the step-by-step again. Okay? To get to the second row, we're going to work across and we're going to work down again. The second row, we're going to start with 4. Who's it going to be matched with? Negative 3. The first of the second row times the first of the first column. So we're going to have, for this entry, 4 times negative 3. Now it's time to go across, so now negative 2. And it's time to go down, negative 2 times negative 4. And we got to finish that row before we move on, so we got to cross over. We're going to go across again. We have to go over the next column. Cross down, then cross over down. 4 times 2 plus negative 2 times 1. Now, I'm not going to show all this work every single time, but we're trying to get used to it. Yeah. It takes getting used to. Something that was easy to forget. We finished the second row. Now is the time to do? Oh, sorry. Hold on. Mental math. Negative 12 plus 8? Negative 4, right? And then 8 minus 2 is 6. So we're almost done. One more set of data. Oh, yeah, nice. So then cross 5 is going to go with first element of the third row with the first element of the column. 5 times negative 3. And Karina was just pointing out, hey, it's going to be nice because now it's just 0 times, which will just be 0. Mental math would be nice. Because 5 times negative 3 is negative 15 plus 0. It's just negative 15. And time to cross over. Still third row. First times first. That's going to be 10. Plus second times second. That's going to be 0.
And if you need like patterns, you can see like negative 3, negative 3, negative 3, negative 4, negative 4, negative 4, 2, 2, 2.
Yeah, the problem is the numbers will always be changing, which is a bummer. I was going to write the long way just so people could see looking back. All right. Final answer is 10 plus 0 is 10. So A times B ends up being, now here's something important you guys need to notice. Ready? In order to be able to cross down, the number of, columns, how many across, first column, second column, has to be the same as the number of rows, first row, second row, or else we cannot cross down, they won't match up. We have to have a first, second, and then we're done. Now, there is an easy way of remembering this, and it all has to do with the order. What is the order of matrix A?
then this
And
way.
what's the order of matrix B?
It's 4
And what's the order of the answer?
plus -2 plus 1.
In order for this to work, these two numbers have to be the same. So the across or the columns have to equal the down or the rows. The inside numbers have to be the same. And what is the answer going to have as its order as long as those two are the same? The outside ones.
So it's,
And if you guys notice up there, isn't that kind of what you wrote in the little boxy thing? The ends have to match, the inners have to match, and the outers show the answer. You see it? So then I said a second ago, hey, AB isn't always BA. Why did I say that? Because if I was to try to find BA, can you guys just read off the matrix to me once I get a new page real fast? Exactly. But to show why real quick. Who is B if I was to go that way to find B times A? And then who would A be? If we try to find B times A, we would start and say, okay, let's do this thing. First times first, second times second. Nobody times the third? It doesn't work. We can't cross down if checking the orders. If these two don't match, it's an impossible problem, meaning they cannot be multiplied. So B times A doesn't exist. B times A is not always A times B because we have to make sure that the orders, the inners match. The number of columns of the first have to match the number of rows of the second. With that, you guys, be amazing. Multiply. You can write as much or as little work as you want. I'm gonna do it too, then we can check. If you're doing mental math, just please be careful. You guys check to make sure it works? Does it work? You know the order of your answer? Yeah, you need to see how. The inners match, we are allowed to do it, the answer is going to be a 3 by 2.
1, 1, 2, 3. All these steps. But the answer, the different is the right is before is 2 plus 3. And then 4 plus 5 plus 6. Make sense?
I am showing a little bit of work just so we can check our steps together. Could you throw us in a calculator to double check? Here's what I got, but you guys double check it out. I was doing it fast and thinking about a couple different things.
I got the last one, but I got 92 plus
0 minus 4 plus 2. 0 plus 5 plus 2 is 17.
17, yeah.
12 and 3 is. Oh, you have to scratch it on the second column, first, second row, first one, right?
Yeah, it's 15.
It's 15.
Yeah, okay. rest of it matches? So could you try to do it totally mental math? Yes, and actually it might even be easier because you can keep it all in your head, but if that's a little too overwhelming, that's okay. You can show the 0 times 2 is 0, that's where that one came from. Negative 1 times 4 is negative 4, that's where that one came from. 2 times 1 is 2, that's where that one came from. Put them all together and there you go. So you can separate the work just a little bit. If you want to see where my very first one came from, I multiplied all of the corresponding. 0 times 2, negative 1 times 4, 2 times 1. I'll show you the very first one. Cross down, and then we went cross over down. The same thing with the same row. We had to go to both columns to get both entries. All right, kiddos. Sadly, that's all we can do with H2 for today. However, we do have some more notes to take on Monday, meaning start H2, and I mean start. I don't mean ignore and procrastinate. Start. And oh, by the way, come tomorrow for girls and my all right. If you have any questions, I'm here today after school.
1, 2, 3. You'll add them all
Or if you can't
together,
come,
they're
text
gonna
second,
be.
that way they know you're here.
I always know. She's going.
Yeah. The
All right,
next one is
I'll
gonna
stop the
be.
recording.